Hey guys, it's me, Mr. Miller. Let's do our 1-3 scientific method notes. Here we go. So what is scientific inquiry? Inquiry is the ways that scientists study the natural world and propose explanations based on the evidence that they are gathering. Now, once we do that, we want to work through some of that evidence through the scientific method. The scientific method is a series of steps that scientists use to answer questions and solve problems. There are 6 main steps that we're going to follow in this class. The first one is to come up with a question. From our question, we form a hypothesis. Then we test our hypothesis. We analyze our data, step 4. Step 5, we draw conclusions. And then finally, step 6, we communicate our results. I like this mnemonic device here at the bottom to help us remember these 6 steps. It's called Question Fred Today After Drawing Class. Alright, the Q in question stands for come up with a question. The F in Fred, form hypothesis. The T in today, test hypothesis. A for analyze results. 5, D for drawing conclusions. And 6, the C in class stands for communicate results. Make sure you rewrite this in your notes to help you remember this phrase, question Fred today after drawing class, for the 6 steps of the scientific method. Let's talk about the first step, coming up with a question. So what you want to do is you always pose a question about an observation that you're seeing. For example, I look at the pizza and I wonder to myself, do 6th graders prefer pepperoni or cheese pizza? Now I'm getting you thinking about lunch. Now you're getting hungry, or even dinner at this time. So that's our first step, question. Second step, we gotta form a hypothesis. Now up here in the top it says a hypothesis. A hypothesis is a possible answer to our scientific question. It is not a fact. It doesn't have to be true. It's just a possible answer to that question that you've come up with. Now, a hypothesis must be 3 things, and these are the 3 things they must be down here. First, it has to be written in an if-then statement. Number 2, it has to be testable. And number 3, it has to be a possible answer to the original scientific question that you came up with. Here's an example hypothesis that I would come up with for our question. If, there's the if part, 6th graders are given a slice of pepperoni and a slice of cheese pizza, then, there's the then piece, then 6th graders will prefer pepperoni pizza. So ask yourself, is that an if-then statement? Yep, there's the if and there's the then. Could I test this and give students pizza? Sure. And finally, is it a possible answer to my original question? Sure it is. So then it must be a good hypothesis. Step 3 is I gotta test it. This is your experiment. This includes your materials list, your step-by-step procedures that you're going to do. And finally, it includes any data charts and tables and observations that you make. Step 4 is you analyze that data. Data are facts gathered through your observations. Okay, it's all the facts, everything that you're getting from your experiment. Analyze means to look for patterns. You make a picture or a graph with your data that you've collected, or you write an analysis. Example. Analysis would be graphing your results, and we graph our results. Now obviously this doesn't have to do with pizza, but at least gives you an example of a pie chart that could be used to graph your data. Step 5 is the drawing conclusion step. This is a summary of what you've learned. This is what were your errors, what were the unknown variables that you came across that you didn't think about that could affect your results. You also examine your results to see if it supports your hypothesis. Did you prove or not prove your hypothesis? If it doesn't, you may need to go back and fix some problems in your experiment, and you may have to experiment again. Alright, so here's an example conclusion that I would write. This is something that you might have to write in one of your lab experiments. Example conclusion. Always start off with, in conclusion, I proved my hypothesis correct. My data and graphs show that 6th graders preferred pepperoni over cheese. 125 students preferred pepperoni while 17 students preferred cheese topping. If I did this experiment again, I would change the pizza company. An unknown variable that I did not consider was whether students had just eaten pizza at lunch. This may have affected my results. Notice how I talked about in conclusion. I said whether I proved or disproved my hypothesis. I actually used the data I collected in my conclusion. I talked about what I would do if I did it again. I also talked about any unknown variables that could have affected my results. This is a good conclusion. The 6th step, Communicating my results. This is where I share my ideas and results with other people. I describe my procedures so others could repeat it to see if they get the same results. Ways to communicate? You can do it through meetings, scientific journals, internet. These are just a few ways. Here's a former Mr. Miller student explaining the scientific method to you.
Man, why can't I open my locker?
I know how you can open your locker with the scientific method.
What's the scientific method?
It's the method for all experiments. You need a question, then you form your hypothesis, then you test your hypothesis, then you analyze your data, then you draw conclusions, and communicate your results.
Well, that sounds cool. Let's try it. So my question could be, can I open my locker with any combination? I think that's a good question, don't you, Megan?
Yes, I do.
Okay, now for a hypothesis. The hypothesis has to be an if-then statement, testable, and a possible answer to your question. So, my hypothesis could be, if I try any combination on my locker, then it will open. Let's test it out. Nope, that one didn't work. That one didn't work either. Woohoo! It worked! I got my locker open. Now, to analyze the data. As you can see, the first one did not work. The second one didn't work either. The third one did work. So, that's analyzing the data. Now for a conclusion.
So, in conclusion, Jordan disproved his hypothesis. His locker won't open with any combination. It'll only open with one.
Now to communicate results. Hi, did you know my locker only opens with one combination? Yeah, it's pretty cool, isn't it? Okay, see ya.
That's
The scientific method.
Alright, there were some of my former students explaining the scientific method to you guys. So you could see all the parts of that in action with just having to open your locker. So every day we're going through the scientific method in our head, whether it's deciding what we're going to have for lunch, how are we going to open our locker, solving problems, whatever. So scientific method's always in action. Alright, you got two flashcards I want you to write. Number 1, hypothesis, and number 2, the 6 steps of the scientific method in order. So make sure you write hypothesis on the front of one card, and then on the back of it, write the definition. And then on card number 2, 6 steps, or just write scientific method, and then on the back, put the 6 steps of the scientific method so you start to learn those. Alright, have your notes and your flashcards done when you come to class. Alright, see you soon.